First of all, hi. Long time no see, and believe it or not, I actually miss you guys. I'm gonna let you know this isn't the first video I've made, but it's gonna look like terrible. It's the first video I made. Made a couple for AP the last couple of days, and I will admit that I need you as an audience in order to be funny. I am absolutely not funny doing this by myself, but I'll do the best I can. Going forward, just a couple thoughts. We're going to be out for quite a long time, and if you're following the news, these dates seem to get longer as it goes on. Right now, state of New Jersey is at earliest 2 weeks from tomorrow. Well, by the time you see this, it'll be today, but 2 weeks from Wednesday. So, where are we when we come back? When we come back, if we come back at that time, and to be quite honest, I don't think we'll be back until after spring break. If we come back at that time, a lot of teachers are going to be rushing to either one, try to catch up, or two, to test what you've done while you were out. So I'm going to let you know a couple of things that I'm going to set up some testing, and I'm thinking I am going to do a test on chapters 12 and 14, and I want to do that for the B-Day class. B-Day, wow, I'm having trouble writing. Forgive me. The B-Day class, I want to do that on Friday. And for the A-Day class, I thought about Saturday, but I didn't want to get yelled at by anybody. So that would be Monday. And I'll give you details about how to take the test online and what I expect from it as soon as I get everything together. Right now, I don't have all of that together. My second concern when we come back is labs. Now, in the AP class, I was just about done with the curriculum. We only had 2 chapters left and 3 labs. But with you folks, the labs are essential. So what I would like to do is to make sure that we're moving forward in the material. And then when we come back, to come back and do the labs. Because with the AP kids, I can do the labs after the AP exam, because the labs we had left, although they're required, very rarely wind up on the AP exam. Your labs, like I said, are essential to your skills and understanding if you're moving into my AP class next year. Last thing I want to mention is with these videos, for uploading purposes on YouTube, I want to keep them under 15 minutes. So if an alarm goes off, I'm going to end the video and then I'll pick it up on another video. The picture of this man here is a teacher. I was told by the administration that you feel a lot more comfortable if you can see a teacher's face while this is going on. So there you go. He teaches how to draw cartoons. I didn't actually click his website. I just typed in teachers working at home, and his face came up. And so he should make you feel very comfortable. So think of him as I'm going through this. And I'm just going to try to, when I go over the notes, to go over them and just add the insight part. And if I practice a problem, I'll ask you to pause the video, try the problem yourself, and then I'll show you how to work it out. And with that said, I'm going to start chapter 12. Okay, for the B-Day class, we did some of this before schools closed last Wednesday. Chapter 12 is about what's called intramolecular forces. And intramolecular means these are the type of forces that keep molecules together. So when we think of ionic bonding and covalent bonding, those are intramolecular forces. And chapter 14 is about intermolecular forces. Intermolecular forces, and that is the force between molecules. And the intramolecular forces have a lot to do with chemical properties, whereas the intermolecular forces have more to do with physical properties. But there is overlap there. And what they all share in common is that all of these forces of attraction are governed by Coulomb's law. So Q1 times Q2 over D squared, and we're familiar with that. So a chemical bond is a relationship between electrons. Sometimes it's one electron from a first atom interacting with an electron from a second atom, and sometimes it's one atom donates both electrons and the other atom doesn't donate anything but empty orbital space. But a chemical bond has to do with the electrons of the first atom attracting the positive nucleus of the second atom. So when they ask this question, what factors affect bonding? And we got to ask ourselves, where are the electrons? And that's all that stuff that we did in chapters 5 and 6 and 10. And those periodic trends play a big part in it. Second thing is we have to take a look at energy. In order to release energy, to stabilize, an atom will move its electrons as close to its nucleus as possible, but you know that those orbitals get filled, and once they're filled, the only option is for the valence electrons to move towards a different positive charge. So you can release energy by moving your electrons towards your own nucleus, but you can also release energy by moving electrons towards another nucleus. Now, in terms of whether or not we have what's called a homolytic bond, which is where each atom donates one electron, or a heterolytic, or what they call a dative bond or coordination bond, has to do with energy requirements. When we talk about mechanism is a step-by-step process. And we're going to talk about two major types, which is ionic and covalent, but both of those have very similar natures to them. If it's easy for something to form a positive charge, it will. If it's easy for another atom to form a negative charge, it will. And the positive and negative is a chemical match made in heaven, right? So that forms a bond. However, what if you get two atoms that have really strong nuclei, really high nuclear charge density? They're pulling on those electrons tightly. There are other ways of doing it. And so we talk about transferring electrons when it's an ionic bond, positive, negative charge, or we share electrons by overlapping the atoms, which is the covalent mechanism. But the truth of the matter is all bonding has a little bit of ionic mechanism to it, a little bit of covalent mechanism. When we say something is an ionic bond, what we really mean to say is that it is mostly ionic mechanism. When it's a covalent bond, we say it's really meaning it's mostly covalent mechanism. In other words, the big deal with covalent bonding is the overlap between the atoms. The big deal with the ionic bond is the charges. So when we go back to Coulomb's law, and we do force equals K times Q1, Q2 over D squared, the Q1 and Q2 is the ionic mechanism, the charges interacting. And the distance squared is the overlap between the atoms, which is the covalent mechanism. But this equation, those factors are in concert with each other. So all covalent bonds involve Q1 and Q2, but that's not the most important thing. The D squared is the most important thing. All ionic bonds involve D squared, but that's not the most important thing. Q1 and Q2 is the most important thing in an ionic bond. All right, electron affinity. We talked about that in chapter 10. That's the ability of the atom to take on a surplus of charge. And we said that the small atoms on the periodic table, like fluorine, chlorine, and oxygen, those are in the upper left corner of the periodic table. Those tend to form negative surplus. So as we move up the periodic table, electron affinity increases. And as we move from left to right across the table, electron affinity increases due to increase the effective force. So if something has a high electron affinity, it can take on that surplus of charge, and it can form a negative charge. It's going to be a good candidate for an ionic bond. Ionization energy. Energy required to remove an electron. If there's very little ionization energy, then the thing is going to form a positive charge. So again, periodic trends, which ones form the positive charges? If we go down to the bottom of the table, francium, cesium, rubidium, etc., and all the way up to hydrogen in column 1, as we go down the column, this increases. Ionization energy decreases. It becomes easier to remove those outer electrons. And as we go from right to left, ionization energy decreases due to less Z effective force. So the things on the left side of the periodic table and towards the bottom tend to be more electropositive, that's the term. They're able to create deficiencies of charge. And those on the upper right side of the periodic table, those have high electron affinities, and they tend to produce a surplus of charge. So that term electropositivity, electronegativity. Again, the more electropositive something is, the more likely it's going to form a positive charge. The more electronegative something is, it's going to form a negative charge. The only difference in terms of periodicity when it comes to electronegativity is that it's just like electron affinity, except electron affinity deals with the atom isolated by itself, where electronegativity deals with what's going on with the atom when it's bonding, right? Because there it is, you can read English, when it's bonding to another atom. But they're pretty much the same thing. Electronegativity increases across a period. Why? Increasing Z effective force. That's all periodic trends going across a period are explained by Z effective force. You have a stronger pull from the nucleus, a very small area that it's acting on, so it's able to suck in those electrons a little closer, and it decreases down a group. Why? Two reasons. As we go down a group, we are increasing energy levels, so we have more quantum energy. The more quantum energy we have, the further away the outermost electron is. And we are also increasing the shielding effect. The more orbitals that we have underneath, it shields the valence electrons from the nucleus. This creates this idea of polarity in a bond. So when we say, for instance, that atoms share electrons, that's what you were taught in middle school, even though you claim you didn't learn anything in middle school. The electrons are not shared equally. The stronger pulling nucleus, the one that's able to disperse charge, the one that's able to accommodate a surplus of charge, the electrons are going to drift towards that atom more than the one that's electropositive. Now, polarity means it has a dipole. And what a dipole is in physics is when you have two sides that are opposites of each other. So a dipole, you would have a positive on one side, a negative on another. So let's say we're creating a molecule here, and this is a water molecule, H2O. Our oxygen would be on the right side, taking on an electron surplus, and it would be sharing those electrons with the two hydrogens, but they're not going to share equally. Oxygen is highly electronegative. It's going to pull the electron charge cloud towards itself, and that's going to create extra electron charge. Whereas the hydrogens are going to lose some of the charge density, and it's going to create a deficiency. So again, thinking of positive as a deficiency of charge and negative as a surplus of charge, because the truth of the matter is when people think of positive, here's the mistake. They start thinking there's no electrons there. That's not true. Hydrogen has an electron. All atoms have an electron. However, when this forms a bond, the charge cloud drifts towards the oxygen. In fact, they draw it, my goodness gracious, they draw it as a vector arrow, like in this diagram. So the red represents an electron charge cloud, and they're saying, look, fluorine is able to pull the electron charge cloud towards itself, so they draw the fluorine with a higher density of charge, and they draw the hydrogen with a lower density, and what you wind up with is this red charge cloud that's asymmetrical. If it's asymmetrical, the charge cloud, then we're dealing with a polar bond, which means that we have a negative, a surplus on one side, and a positive on the other side. Okay, I'm going to stop here and I'm going to pick up the video on another post. So